Good morning, students. Today we are going to see a topic in robotics third unit. We are going to see this topic under the sensors, the types of sensors. Today we are going to see about the range sensor and tactile sensors. Already we are seeing about the sensor and its types. Today we are going to see about first we are going to see range sensor, and next we are going to see the tactile sensor. This is the syllabus for the unit 3. Range sensor or range finder. Two methods are used for this finding the range using the range sensor. One is the ultrasonic method, ultrasonic sound method, and another one is the laser light method. One is using the sound and another one is using the light. These are the two technologies used for finding the range sensor or range finder. Basically, the range is the distance at which an object is present from the sensor. It is found by the time of the flight. Time of the flight in the sense the time taken by the sound or laser or ultrasonic sound to reach an object and to return to the sensor. With this time only, these range sensors find the range or distance. Range sensor is basically finding the distance of the object to the sensor. The main application of this range sensor in mechanical field, if we see, is these range sensor are used in the industry in the automatic vehicle systems. For example, if they are using a vehicle guidance system, the vehicle must move in a direction, and these range sensor are used to find if there is any obstacles in that area, so that if there is an obstacle they can change their path. This range sensor is used to find the obstacle and the distance at which the obstacle is present from the sensor. So these are the main uses or application of range sensor in our mechanical field. Okay, the first point is the time of flight. With the time of an obstacle, the sensor is using the light or sound. The time the light or sound reaches the obstacle and again reaches back the sensor. With that time only, this range sensor is calculating the range or distance. The next point, it measures the measured pulses typically come from ultrasonic RF and the optical energy sources. It is given by the equation D is equal to V star T. D is the distance, round trip distance. The distance only we are going to find. We are using the speed of the wave propagation by multiplying it with the time elapsed. Okay. Next, the first type of this range sensor, ultrasonic range sensors. The basic principle of operation of the ultrasonic range sensor is it emits a quick burst ultrasound. This ultrasound travels in a particular direction in a particular time and hits the obstacle or object, and this echoes back to the sensor by the distance and the formula we given in the previous page. With this we are finding the sensor finds the range or distance. This diagram shows briefly about the ultrasonic range sensor. The transmitter transmits the sound and it hits the object or obstacle, and that is received by the receiver. And with the time and the distance, the range is found out. The next type, the first type is ultrasonic range sensor. The second type is we are using ultrasonic sound there. Now the second type is laser range sensor. This also use the same principle, but instead of ultrasonic sound, we are using the laser light in this principle. The laser light is passed and it hits the object and it reflected back to the receiver. With this, it is able to found the range. The laser rangefinder work by emitting the laser beam from the bottom. These beam bounce on the objects, and it get reflected back to the receiver, and with the distance and the time, the range or distance is calculated. The main applications of these range sensors is in the robotics. It is used for navigation, that is the movement of the robot. If the robot finds any obstacles, it will change its direction for this, and that is the second point. It is given obstacle avoidance. Okay, these are the main applications of this range sensor in the robotics. Now we are going to see the comparison between contact and non-contact type of sensors. In the contact type sensor, the tachometer has to be in the physical contact with the rotating shaft. But on the other hand, in the non-contact type, there is no need of a physical contact with the rotating shaft. In the contact type, it is preferred where the tachometer is generally fixed to the machine. But in the non-contact type, the tachometer should be mobile, or it must move. The next type is touch or tactile sensor. A tactile sensor is a device that measures the information arising from the physical interaction with its environment. Okay, these tactile or touch sensor are mainly used, even it is used in our college also. We are using the attendance, the fingerprint attendance. In this type, these tactile sensor only used. With the touch, it detects the information. So this is the main application or use of these tactile or touch sensors. In the figure, it is a grid of tactile is given. These grid collect the information from because of the touch or because of the touch. Usually an array of discrete sensing elements. These tactile sensors are an array of sensing elements. These sensing elements are divided into many types. The first type is resistive. The resistive is divided into strain gauge and piezo resistive. Then second one is capacitive. The third one is piezoelectric, and many other magnetic, optical, and conductivity ultrasonics. Resistive sensing elements. The resistive sensing element, the first type is strain gauge. In the strain gauge, a thin film having a metal pattern that changes the resistance when it is strained. Then the second one is piezoresistive element. The pressure on the element causes the material to compress, changing its resistance. Now we are going to see about the advantages and disadvantages of these resistive sensing elements. The advantage is it is very simple in construction, it is very durable, and it has a good dynamic range, and it is very easy to read out the informations. The disadvantage is it has a non-linearity, and the sensitivity is very low in this resistive sensing elements. This resistive sensing element is given by a formula R is equal to rho star L by A, where R is the resistance of the conducting material, rho is the resistivity, L is the length, and A is the cross-sectional area. Capacitive sensing element, second one. In this, the mechanical deformation changes the capacitance of parallel conducting plates. It is given by the equation C is equal to epsilon A by D, where C is the capacitance in farads, epsilon is the permittivity of dielectric, A is the area of the plate overlap in square meters, D is the distance between the two plates in meters. In general, these tactile sensors are used to sense the contact of fingertips of a robot with an object. They are also used in manufacturing of touch display screens, of visual units, of CNC machine tools. This tactile sensor has two layers, a PVDF layer separated by a soft film which transmits these vibrations. An alternating current is applied to the lower PVDF layer which generates the vibrations due to the reverse piezoelectric effect. These vibrations are transmitted to the upper PVDF layer via soft film. These vibrations causes alternating voltage across the layer. When some pressure is applied on the upper PVDF layer, these vibrations get affected and the output voltage changes. This triggers a switch on or an action in robots or touch display. This is the working how the touch action of the how the touch display works. Okay, now with this we have come to the end of these two sensor types. Thank you.